Welcome back to the third video in this series on hardware. Here we have another output device, the point-of-sale terminal. This is what one will find quite often at the checkout counter of any retail outlet. A monitor, a printer, and a cash drawer. 3 output devices in one. This is another one of those technologies that have transformed business. Nothing really special here. This is just another form of speakers, the headset. It is, however, another example of an output device that is available for one's computer. Now let's explore the process function of the computer. In the early days of computing, there were a number of devices, as you see here, that worked together to handle the loading and processing of instructions. One of the machines held the RAM or primary memory that the computer would use. One of the devices was called a control unit that decoded the instructions and then either executed the instruction or directed one of the other devices to perform some function. There was the arithmetic logic unit that performed all of the arithmetic operations and made all of the logic decisions. There was the address register that held instruction addresses during processing, and also multiple general purpose registers that served as temporary storage while instructions were being executed. Then in 1971, Intel invented the microprocessor, which combined all of those machines you saw in the previous slide into a single silicon chip. Here you see an early Intel microprocessor, and this one is a modern i7 microprocessor from Intel. The microprocessor is the real brain of the system. Everything else is simply storage, data paths, and peripheral devices. Here is a schematic of a microprocessor. Here you see the instruction decoder, that would be the control unit. There's the instruction register. These are data paths, which are really just pathways that data will flow. Here is the couple of these general purpose registers, register A, B, and C. And here you see the arithmetic logic unit. That is a schematic of a typical microprocessor. The system board, or motherboard, is bolted to the case of the computer and serves the function of holding a number of components used in processing. These include the microprocessor itself, the RAM, along with input-output ports for adding other kinds of special-purpose circuit boards. Here you see where the microprocessor would have been plugged into this board. Right here are the slots that hold the random access memory, or RAM. Here are input-output ports that allow you to plug other types of devices into your computer that maybe were not thought of when the board was made. And then there's many other components. Take a look here at the back. You see some ports that this part would be sticking out the back of the computer. Here is a close-up of RAM slots, and this is a memory chip right here. This is the rear of a modern motherboard. If you look at the back of your computer, something similar will be there. There are a variety of ports that allow one to connect other devices to the computer. There are some audio ports right there. There is a network port. These look like a couple of USB ports. There is an HDMI port to hook your high-definition television to your computer. This is a typical video port. This is also a monitor or video port. Different kinds of video technology there, but they both do the same thing. Here one would plug in a mouse or a keyboard, and looks like we've got some more USBs right here. Very nice motherboard. Now let's talk about the various classes of computer systems. The mainframe is the traditional large multi-user multitasking system. This would be found in larger organizations and would be interfaced with the network and other systems. It would require a large IT department and a great deal of management. The supercomputer is a very powerful special-purpose computer capable of very high-speed processing and might be found tracking weather patterns or objects flying through space. The embedded computer is just another special-purpose computer that might be found controlling your car or a passenger jet or making your refrigerator work. And then there is the microcomputer, normally a single-user machine dedicated for your use. The microcomputer is available in many forms. The desktop that you might find in the computer lab at school or at home. The laptop, which is basically a portable version of the desktop that is small, lightweight, and sometimes very powerful. The tablet could be considered a special purpose microcomputer because it offers some excellent features and capabilities, but is not always a very effective solution for the traditional data processing activities that we do, in part because of the lack of a keyboard and other resources and software. It is great though for mobile computing and browsing the internet. And of course there's a smartphone that performs activities similar to those of the tablet, in that it is excellent for mobile computing, allowing one to access any number of useful sites and run a variety of apps that assist us in our daily activities. It might be a stretch to call either a tablet or a smartphone a microcomputer, but all in all they do meet the description of a microcomputer. As we finish this set of videos on hardware, let's touch on another topic that is slightly off subject. As I write the scripts for these lectures, I occasionally struggle with the wording of an idea. The goal is to state this information in a manner that we can all understand. So, from time to time, I will check with other sources to see how they word the idea. My favorite resource for this is Wikipedia. Now, there are professors who do not allow Wikipedia as a source for research. I just don't happen to be one of them. That said, I don't mean to suggest that I trust everything I read on Wikipedia. I do not. Nor do I trust everything I read on any other source. One of the goals of an institution of higher learning like ours is to enable our graduates to be skeptical, let's say. We call it critical thinking. The ability to consider the potential impact of our choices as an example. All of us must consider what we see and hear with a critical eye and ear. As it happens, I don't need some source to explain the issues I'm presenting to you. I simply refer to those other sources for a better wording of an idea, confirmation that I'm not misstating the idea, and as a source of perhaps some additional material on the idea. As you progress through your careers, both academic and professional, I hope you will take advantage of the vast amount of resources that this technology provides. There are more videos to come in this and other sections. I look forward to talking to you some more.